I think, let me plug this in. I think you should be okay now, right? Okay. All right. Sorry about that. When I didn't bring my headphones today and I'm at work or on the campus. And so my computer is configured to use the headphone. Anyway, so today we are going to cover patterns, and patterns are going to be design patterns. You often see this with object-oriented programming. And so you will have to implement classes and subclass in various patterns. Now for the final project, you are required to use one form of pattern. You don't have to use them all, but today we want to present to you the type of patterns that you can incorporate in Python programming. So we'll start out with chapter 23, and then we're going to go to chapter 30. I optimistically was hopeful to do 33 plus, but that was a lot. So I think we're going to cover the major patterns, and if you wish to do the other ones, if you have the textbook, you can also cover that, but documentations are well provided for these. So when you read into the patterns this week, you are going to find out that the Gang of Four is the book that this chapter or these chapter reference. And when you look up the documentation for these patterns or other type of books and chapters and things like that, you will also find a reference of Gang of Four books. Okay, so that will be the book for patterns. I also included a link for patterns and idioms tests, and you can read the documentation, and it explained the pattern concepts and give you some example there as well. That's also another common book that's digital, that's free. So design patterns are simply reusable program solutions that can be applied to various contexts, and we're going to look at some example today. And if we want to produce a certain type of results, we would apply appropriate pattern. And this is implemented in object-oriented programming, which use class object. Okay. So there are 23 patterns that are really divided into 3 categories. And we are mostly covering creational and structural. So the first category is creational pattern, and this is how an object can be created. It also involves the details on how we would be able to use one object to generate another copy of an object and so on. So your code isn't dependent on the type of objects, but it doesn't really has to be changed as you add the new object. So it's a way that we will work with an object in our program, and we can reuse that pattern to throughout our program to produce a certain result that you want, like in business applications and widgets and a lot of different things that we do. So pattern is exactly what it means, is that it's a way for us to create some kind of structure that would repeated throughout our program or being reused throughout our program. The second category is going to be structural pattern. And this is a way that we can design objects that would fulfill a certain constraint. In that it would relate to other objects to ensure that changes of the system doesn't require the change of those connections. So if we have certain limitation or certain requirement, we would apply structural pattern. And then the third category is going to be behavior pattern. And this is going to handle through the actions within the program. It will be a process that you want to implement, interpret the language, and fulfill the request through a sequence or implementing an algorithm. So it's mostly looking at behavior, and you would see this in automations a little bit. So we'll start with the creational pattern, and this is going to go into factory. So factory is going to be this factory design pattern is broken into two parts. One is going to be the method. Second is going to be the abstract. So the design pattern for factory is it's easy to track objects where it would be all centralized. It would reduce the complexity in the application by decoupling the code. And it's creating a class called factory in that we would use it to create new types of objects. And we would disperse the objects and use the objects with different attributes through our program. So in machine learning, you would see this now being used, and also you would see factory also being used in data analytics and so on. And it has a creation what's called feature stores, in that you can have it online or offline to be able to work with abstract data. So it works directly with data, and you can use it for many different type of application. We'll take a look at those. Okay. So as I mentioned, factories have two forms, factory method and abstract factory. An abstract factory is a group of factory methods. So when you have more than one, you would then use abstract factory. And the factory method basically is a function that returns different object per input parameter. So we can have input as XML or JSON, right? We don't necessarily have to wait for the user to enter text. Let's say that you have a set of data that you obtain from the internet, and that usually comes in as XML. Then you can have the program read the data using factory method and be able to output something. So for example, you have a list of products and its description, right? Like in the example we're going to look at, it's going to be movies. So you have movie titles and the year it was produced, and actors and so on. So there are different elements that you can pull, and you can also use this with database file. So if you have like a SQL file or using SQLite or even SQL, then you can also use factory method or factory abstract to be able to create a program that would read or input the data from those type of files. So for web-based, you can use Django framework with factory method to create fields from web forms. So if we have a form where the user will enter their name, their address, their phone number, their email address information, possibly their income for maybe loan qualifications or loan applications and so on, we would use Django framework in order to do that. And all the data that's inputted would then be placed into some form of database, or we can use JSON to be able to parse that. Okay. So this is a really simple example on how you would create a class. With class A, we use a pass keyword where we don't have any kind of functional body for that class. And then we would have a main statement in that we create A and B object, and we will be able to print out the ID, which is the memory location of your object. Okay, so it shows here that object A and object B exist in two separate locations, not in the same location. So it's a way that we would be able to store and retrieve data, and your data is going to tie to the objects that you create using the pattern. So the below section, it talks about file categories and how we would use XML, YAML, RSS Atom, or JSON. Those are human readable files, and they tend to parse slower than your binary file, but making data exchange and inspection, because it's human readable, it's easier. In binary file, we would see that with database file like your SQLite, such as SQ3, or in the case of audio, we would be MP3 and MP4 for video and so on. So those are the type of binary files that we might work with. So if you built like a website where you would be able to upload and download videos or audios, then you would be able to store those files into a database and then be able to pull the database file and parse it. Okay. So abstract factory simply is a group of factory methods that would be having a family of related objects, whereas factory method is a single function, right, that can be used. So let's answer some questions. 1 second, let me get my file back up here. So for question 1, it asks you, what is a design pattern? And as you're required to use design pattern in your project, we want to know what it is. They are reusable program solutions that can be applied to various contexts and have proved to produce expected results. And as I explained, there are 3 categories of design patterns. You don't have to put those verbatim, and you can take them from your notes. Your creational pattern, how an object can be created. It would be involving the details of object creation. Structural patterns, that will be designing objects to satisfy constraints. Depending on your project, of course, or your program, right? These work in the way that objects relate to other objects to ensure that the changes in the system don't require the change to those connections. And then third, we have a behavior pattern that will handle actions within the program. So you would incorporate processes that you want to perform, such as interpreting language, like if you use language translator program that will incorporate behavior patterns, fulfilling a request like web requests, moving through a sequence like using an iterator, or if you're implementing computational algorithm, that would use behavior pattern. And so these really elevate your program on how you would design an OOP, right? An object-oriented program, and how you would approach objects and its classes. So how we distinguish between factory method and abstract factory design pattern would be that a factory method is a function that returns different object per input parameter, whereas an abstract factory is a group of factory methods where each method is responsible for generating different kind of object. So when we use the factory method, that's simply a function that return different object per input parameter. And you will see this in our example. And for the abstract factory, we said that it's a group of methods. So you would get each method is going to be responsible for each kind of object. And you want them to be independent. Any question? So the notes is extra lengthy in that we have to cover multiple chapters, but a lot of it goes to the code, the example program, and I cut out some of the snippet in the text because, you know, if you understand the actual procedure that was implemented for the program, I think it simply is really easy to read the code. So by this time you should be able to identify like what is an object, what is a class, how methods are implemented, and so on. So um, let's take a look at your factory method example. And if you have the link to download, right, you can find these as well, but I also paste that into your notes. And you can run them on Tawny or your interpreter, that Python interpreter, that should be fine. So here is the program for our factory method. And since we are using input in JSON, we need to import JSON. Okay. And then we are also using XML input. So we are using the module element tree, which also is a way that we can incorporate XML parse. Okay, to parse in XML. So we define two classes. One is going to be the extractor for JSON. The second is going to be the XML data extractor. And in the first class, we instantiate, right, our object. So here we are going to build a dictionary that's going to contain our data, and that's going to be pulled from the JSON file, which I also uploaded onto the note page. So when you run it, you need to make sure that that file is together with this particular program. Okay, so put it in the same folder and then you can run it. Otherwise, it's gonna give you an error. Then we have a with open statement. So it's gonna read the file, and because it is encoding with UTF-8, right? We want to be able to parse the file using the encoding there. And then that's gonna be F is the object when it reads that. Then to load the data, it's gonna load F, and that is a JSON file. So what am I talking about here is, go here. There is a data file called movies.json. This is a file that we are gonna input into the program, so it's gonna read this file. And the second file is gonna be the XML file called person. And this is, it's gonna also be inputting. It's gonna use this file as an input. So here we have a decorator for property, and we define a method called parse data. And we're gonna return the data. So it's gonna read and return the data. Second class, similar, but this one is for the XML file. We instantiated the object, and we are going to parse for XML. We again use the decorator for property. Then we define a method that's going to return the data from the XML. So the definition for the function is here. If, right, the file ends with JSON, it's going to extract using, and we call the JSON data extractor here, which will define the class up here. So its member method would then be used. If the file ends with XML, then we would use the XML data extractor. And again, we define the class here. So within it, it has the member method. So it's then going to use that accordingly. else we are going to raise an exception, and it would tell us that it cannot extract the data from the given file path. So if your data is missing, then it's going to skip these two and it's going to go to the else where it would raise the exception. The next is going to be your factory object. And we are going to do a try and except to catch the error. So here we define an extract data from, and in it we will use a factory object. And we are going to use that for as a factory. So your method factory exists here. Okay, so here it's going to try to catch the exception. And if it's a value error, it's going to print the error. Otherwise, it's going to return the content of the object. Then we define a main function. And in the main function, we initialize SQLite factory, which is the SQLite file, the persons.sq3. That's your binary file. And then we're going to print. For our JSON factory, remember that these are separate factories. Okay, so they are different objects. Remember we talked about individual object for individual action. So when we use it for SQL, we would treat it as a separate object. And for JSON, we would treat it as a separate object. So this is going to be for the movies.json file. And the path is where you specify. So it's in the data folder. So that's why you see data / and then file name. So wherever you place it, you have to make sure that you include that path in the parameter here. And then we are going to print. So in the print, we are going to look for movies information from the JSON file, like the title, the year it was created, and then the director. And that's being pulled from your JSON file in the genre. Then for the XML factory, when we pull the person.xml, we have liars as it's going to store last name. That would be liar. And then it's going to print. So as we loop through that, we would print out first name, last name, right? And the attribute where it finds the phone number and so on. Then lastly, we have a main, right? Where we call main. So after we define the main, we simply call main. So when you run this, let me clear this. Sorry, let me rerun it again. So the first thing it tells me that it cannot extract the data from data person.sql3, but it did give me the movies.json, right? So it found 9 movies and it lists the title, the year, the title, the year, and so on. And then when the title is in the year with the director, and okay, then next we are going to also extract file from persons.sql or .sql3, and it's able to find 2 people with the last name Liar. So it's going to give me 2 people, Jimmy Liar and Patty Liar. and their home phone number and their mobile number on the second one. So the numbers are the attributes in those records. So as you can see here, right? So ideally we would use different code for different type of file input for different objective of our program, right? We don't necessarily combine it like this, and the text talks about that. Okay, so let's say that you are creating an application that goes through and do a search on a certain movie. Then you would be able to read like this. So you would have a database of movie from a certain year to certain year, right? Where the user can search through the year or the title or, director or genre. And this is what you kind of see on Netflix, where it is an app that you use on your smart device, and then you simply would be able to search through and it would go to the database and retrieve that for you. Okay. Or we can do like a directory search, like what you would see with yellow or white pages, or a lot of different types of website, right? Where it would retrieve the people, email, address, phone number, and so on, okay, based on the criteria that you set there. Any question? So this is at the simplest level. That's what you see with the factory method. And you can find a lot of publicly available data for different things outside of just movies and persons that based on the example. Okay, so let's take a look at the abstract. Let me clear this. A little bit longer. So this is a game that was presented, and I think this is an example from the book, the link that I provided at the top. So this is a Frog World game. So there are two choices in this game. One is for kids and one is for adult. Let's say that we want to have two separate versions, right? The PG-13 version and the adult version. So here in the abstract, we define frog class. Okay. And so when you look at the implementation, it walks you through on how those would be. Okay. So you first define the frog and bug classes for the game. Then you would add the frog world class where we would use frog and bug classes. Then we would define wizard and orc classes. That will be the wizard world game. Then we would add the wizard world class to be used with those two classes that we define. And then we will define a game environment class. We want to validate the age from the user input. And then we would use the main function to obtain the user input for name and age. Then we would decide on which class we would send the user to. So if they're under 18, we would give them the PG-13 version or the kids version. And then if they're over 18, we would give them the adult version. So we would use this to branch the decision on which direction the program would take based on the user input. And then we simply call the play function or method in the environment to play the game. So let's take a look closer. Okay, so we have the frog class. And we have the bug class. So the frog eats the bug, and that's the kids version. So then in the frog world, we would then be able to use, right, what we have defined in the frog and the bug, where we would have a function to make the character and return, here is your frog class, and here is your bug class. That will be the obstacle. So that's the kids version where the frog eat the bug. Then for the adult version, we define two classes, wizard and orc. And similar to the other ones, right? After we define these, interact with, and for the action to kill, okay? So then in the wizard world, we would then use those classes when we make the character and we make the obstacle. And the string here just to display, just to output the string. Then the next part is going to be our game environment. Where here is where we would set up the factory. And we would define a play method, okay, where we would call the interact with, and then we would do the obstacle. So whether it's the frog eat the bug or the wizard kill the orc. And we have a method called validate age. This is where we would do a try and accept. So we want to check for the age input. So input, ask the user how old they are, and then store that into each variable, right? And then we want to do input validation here. So if they don't input a value, then we would ask them to input it again. In the main function, we would define what name is, and we would prompt the user to enter their name and store that into the name variable. Then we want to set valid input as false. Then we have a while loop. And we want to validate the age input. Then we define what game would be. And here is where we call frog world. If they're under 18, or anybody that's older would be wizard world. And those are the two classes that you previously defined. So it's going to branch there. Then our environment is going to be our game environment, which is this class right here. And our object, which is game. And then it's going to specify the name. So it's going to plug that in, and then we are going to call the play method. So when we run this, so as I am an adult, right, I would get the wizard world, and it plugs my name in, and it says Casey, the wizard battles against an evil orc and kills it. But if I run this program again, and I put in my name, let's say I'm 12, and it's going to take me to frog world, where it's going to tell me that the frog eats the bug. So as you can see with this one, what we did was we created the classes, Okay. And then we also have the objects. And since we have multiple factoring methods, we would use abstract factory in that that happens here in our separate class that will be game environment. So that's a little bit different than what you've seen in the last one where hero and obstacle becomes, right? We would group them into one class. Any question? So that's one way of, another way of using your design pattern. Next, we're going to talk about builder pattern. And builder pattern is a way that we would construct more complex objects and how we want to represent it. This is a creational design pattern. Unlike other type of pattern, it doesn't require products to have common interface. And so it is possible to use different products for the same construction process, hence the name builder. And you can implement step-by-step procedure for the builder pattern, and it uses it's independent from other objects. So in the example program, you will see that there are two components. One is the builder and one is the director. The builder is responsible for creating parts of the complex object, whereas the director is going to be controlling the process. And so now most of you are probably familiar with this if you ever use some kind of pizza app like Domino's or Pizza Hut or Instacart. A lot of the newer apps for delivery, it gives you progress tracking on what you have ordered, whether they're fulfilling the request, if it's on the way, and so on. So in this particular example, we are going to examine a pizza building progress, where when you place an order, that request is going to go through, and then based on your order, what kind of pizza it is, it's going to show the type of, ingredients that would use and how they cook the pizza and deliver the pizza. Okay. So before we look at that program, let's answer some of the questions first. Number 4, the advantages of the builder design pattern in that it provides clear separation of unique layer between the construction and representation of the object created by class. It also allows you to better control the overall process in the pattern. And it provides perfect scenario to change the internal representation of the object. So you are able to use different interfaces with these. And some of these, you will see that the pattern is adaptable with different interfaces. And the two components of the builder pattern, we talked about the builder and the director. The builder is the component that create the complex object, various parts of it. And the director is what control the building process. Okay. Any question on builder? clear this. So here in this one, we are going to use enum and time. And pizza progress is an object of enum, right? And we want to just queue the process. Pizza dough is also another object where we would use that for thin or thick dough, and then our sauce and our topping. We're gonna have 3 seconds delay. For our first class, that will be pizza. And we instantiated name, dough, sauce, and topping. And topping is a list. Then for our member method, we would have preparing the dough, and here is where you have dough is dough, right? We are preparing the dough. We're gonna have it pause. Then we're gonna say done with dough. Okay. So now realistically on this type of program, right, your chef or the baker, the cook would then need to update. Or you can have it time where in a fast food restaurant like Pizza Hut or Domino, they would have, let's say, 5 minutes to prepare the dough. And so we would pause it for 5 minutes and then we would update it. But as they put it in the oven or, you know, put the topping on and stuff like that, they would be able to press a button and it would update the system, which updates the app, which update our website and the user. Then we have another class called Margarita Builder. And this is for the type of pizza, margarita. So our pizza would then be an object of the pizza class. And for our arguments, we would have margarita. Then we are going to use the progress, right, to queue. And then we're going to have the second to be able to wait. So 5. Then another method is going to be preparing the dough. We have progress. That will be part of the pizza progress. And then this is going to be thin for the dough. So the attribute, you would see that there. Then we're going to add the sauce, put in the sauce, which is your pizza sauce right here. And that will be tomato. We're going to have it sleep and then print. Then next is going to be topping. So we are going to bring in the toppings, which is your mozzarella and oregano. We're going to add the topping. So it's going to append that and it's going to loop through the items. Then wait. And then print done with topping. And then now oven time, so bake. So your progress is part of pizza progress. And this time it's going to be baking. Then print for the update. Then put in the wait time, which is sleep. Then now we are going to make it ready. So now it's going to use ready for pizza progress. Now, different than the margarita, we have another class that does different sauce, right? Different dough, different topping, and so on. So what happens is that you're able to reuse, right? As you can see, reuse some of what previously defined at the top, but treat them as separate independent objects. So here our toppings are completely different. Our sauce is completely different, and our dough is completely different for the second type of pizza. Then we have the next class called the waiter. And the waiter is then going to be the builder. So here is where you see that we specify the builder. And we would do a builder dot prepare dough, add sauce, add topping, and bake. Doesn't matter what type of pizza that you had, but you are building based on the user choice. Decorator property. And then we are going to have a method called pizza. We're going to return builder.pizza. Now the next part is for input validation. We're going to prompt the user what kind of pizza would they like, M for margarita and C for creamy bacon. Then we're going to take that input and store it into pizza style variable. Our builder here is declare as builder, and then we are going to take what's in pizza style and put that there, store it there, and then we're going to validate the input. If they didn't key in M or C, right, we are going to prompt them, sorry, only these are the choices, and then they need to re-enter. Then in the main, we would declare builders as a dictionary. That will be margarita or creamy bacon builder. And then for validate input is false, we would then keep asking for the user to enter. So we're going to print, and our waiter object here is going to be part of the waiter class. Our waiter construct pizza builder. Our pizza object is part of the waiter pizza. Then we're going to print enjoy your pizza. Okay, and main, if its namespace is main, we're going to call main. So when we run this program, so let's say I go with C, and it's going to now go through preparing the dough with thick dough. As you can see that it branches between thick and thin, right? And then it's going to be done with thick dough, then add the sauce, done with the sauce, add the topping, done with the topping, and then bake, wait, right? And then it's ready, and then enjoy. So as you can see how, right, this pattern is applied using the builder. Any question? And this can be applied for other form of program too. This is like just an easier way for you to see it. The book also provide other example. Let me show you. Like a computer builder application where you can choose, right, the type of hard drive, memory, graphic cards, and so on. And also this one, we're also using a builder. So when we run this, right, it tells us the type of memory, hard disk, and graphic cards that's used on the computer. But you can make it where user would be inputting, and kind of like the pizza one, and you'll be able to be able to customize the shopping experience for the user that way too. Those are some of the example. That will be for the builder. Let's see. So in this section, it talks about the Fluent Builder. The Fluent Builder would then calls the builder methods that are chain. You can define the builder as the inner class and return that as a setter-like method. So you can incorporate the Fluent Builder into your program. And this is like an addition to the actual builder pizza program that you had. Let's see. So we answered the builder and the director. Next, we're going to talk about prototyping or prototype pattern. So now we're going to take a look at structural and other creational and structural type of pattern. So the next two type is the creational pattern. Prototype is useful when you need to create an object based on an existing one, and it's usually a copy. So it's a deep copy. It basically copied the object structure to produce a new object. So in the example program here, this is a way that we can do an inventory of all the website domains. And you do see this available on the web, where if you use like whois, right, it will tell you the domain, like who hosts that domain, what IP address, the public IP information, and who owns that website. So in the example program, it gives you a similar set of information. So just to overview this, you can go to the implementation section. So we are going to use copy module. We are going to define the website class where it's going to instantiate the string representation of the method. Very similar to what you see with the pizza. Then we're going to define the prototype class. And then lastly, we're going to define the main function, in that we would have keyword lists and your website class to call site 1. And to create the prototype object, it's going to use the register method. And it's going to clone site 1 to be site 2. And it's going to display the result for both objects. So to define prototype, as we say that it is a pattern that is used for copying the object structure to produce a new object. It creates a deep copy of the object. Question: could this program be converted to a factory method pattern? Yes, you can. So Michelle asked, are you asking about the prototype pattern or the builder pattern? The builder, okay. Yes, you can actually make it into the abstract program from the builder pattern. Now, all you have to do is, so in the margarita and the creamy bacon, we can treat it as two factory objects. And so we can make it into an abstract factory. That's what I would do. Because you have separate methods that's treated for different things in the pizza building process, right? We have crusts, we have toppings, we have, right? Those are independent objects. So then you can make it into like a factory abstract. But as far as the prototype, we'll take a look at that. Okay, so again, prototype is making a copy of the object structure and produce another new object. Okay, then let's look at number 5. Let's clear this. So here we have a class called website. We instantiated, okay, for name, domain, description, and author. And then here is our string representations. And under that method, we would have summary variable. This is going to store website, and then we're going to bring down the name. And for the information, we're going to use the items method to be able to pull that. And then we want to sort the information alphabetically. We have a for loop, and that is going to give us, so as it loops, it's going to organize it. It's going to give us the details for the information. Remember that we're accessing content in a dictionary format, so that's why we're using the items, and we can sort them, and we would use the for loop. Then we would append actual name, which is the attribute, okay, and its value. And we're gonna use join and put that into summary. In the class prototype, we would have instantiate for the dictionary. And here we have registered website and unregistered website. And for our clone, we would use the identifier, okay, of our object. So it's going to get the identifier of the object. Because it's doing a deep copy, it's simply just recreate another object based on what the construct of the prior objects. If it's not found, then it's going to give you a value error. So that's an exception. And here is where we're going to make a copy if it's found. So as it looks through that, right, at the memory location, it's going to identify the object. And if it found it, we're going to make a copy. And we're going to use a for loop to be able to obtain all the attributes and return the object. Then in the main, we would declare what keywords would be. And it is a tuple. Our keyword would be Python, data, APIs, and automation. Our websites, content gardening, domain, description, author, and blog, right? For site 1, and then for site 2, right? Some general information for the site 2. So our goal is to be able to clone site 1 for site 2. And when we print, we want to print the ID to look at the memory location if it's matching. Okay, so here it tells us first that we can see that the objects are 2 separate objects. They are not in the same memory location when we print out the ID there. Okay. And when we print the content, this is just for verification for site 2 that is hard coded in, right, for your keywords and creational date and so on. But the point in this is that you do prototype by using the prototype class and your prototype object. Your identifier is going to be KA, CG, and 1. And so that is used when we call the clone here for the site 2. Even though we're outputting different strings there, right? So the whole point is to make sure that they are separate independent objects when you clone them. Question. Okay. So that's an example for prototype. Next is going to be Singleton, which is another form of it's another form of creational pattern. So Singleton, as its name, it's going to be restricted to 1 class, 1 object. Okay, that's a singleton. Simple. 1 class, right, where you can have different methods for different objects. You can restrict the instantiation to a class to 1 object, where you would need 1 object to coordinate all the action for your system. And you can also prevent cloning using Singleton. So it's different from your prototype in that you cannot clone on this one. The example that's used in the text is a program that tracks a list of web pages. Okay, and this example is actually really short. Clear this. And let's go with this. So we're using URL lib parse and request. That's mainly for URL website tracking purposes for the program. We have a singleton type class we instantiate, and this is going to be, your instance is going to be a dictionary. And this is a super class. Okay. So for our instances, that's going to be, here we're going to use super keyword. And for our call and their arguments, we're going to return the instances. The second class we have is going to be URL fetcher. And we are going to use the meta class singleton type, which previously defined. we are going to instantiate the URLs list. In that, we have a member method called fetch. And our rec is going to be our request. So here we would use request method from URL lib request. We are going to open the request, right? And if it's successful, which is 200 code, then we're going to read the page and print it. And then we're going to append the URL. Now the next method is going to be dump URL registry. So it's going to return using join method of the URL. In the main, we have to define what the URL is for. So here are all the websites that we're going to try to request: void space, google.com, python.org, and python.org/error. We wanted to see also successful and error in this. We're going to print. So here we are going to use URL fetcher, which we define as the class above. Right here. So fetcher is an object of URL fetcher. And we have to have a for loop to go through all the URLs that are defined in the main here. And we are going to catch exception. So try, we're going to fetch the URL. In the case it has exception, we're going to print the error. And when we finish, right, we're going to display the URLs that's done. And then if namespace main, then we call main. So we are going to run this. It's going to take a few seconds. So we do see some error, right? And then we're getting a 404 where it didn't find one of the URL. And then it printed for us the done URL for the Google. Okay. So as you can see, by definition, Singleton Pattern implements a class from which you can create an object. And as you use it for URL tracking or request tracking, we can simply implement Singleton. But if it's like a business program, we want to consider other pattern where other patterns will make more sense. So these patterns really correlate with how you would look at the business context of your program in how you would approach the design. That's why we have variations of different patterns. Any question? So you can take a look at the program, you can run it. Most of the program don't require additional files except some of the later ones. I didn't get a chance to upload it, but I can upload some of the additional file for you. Okay. Next, we're going to take a look at the adapter pattern. This is in chapter 26. Now we're entering the structural design pattern. So when you think of the term adapter, right, we think of like how we would interface two different things. So if, for example, if I have a computer that only use, let's say I have a MacBook and I want to plug in USB drives to my MacBook, and I don't have a USB port, but I have other type of port. So I would buy an adapter to be able to adapt the existing port for USB. Same thing with, like, if I have an old PC and I don't have a certain type of connection, I can buy an adapter that I can install on my computer to be able to adapt it for other use, for the components that I would have, that I would need. Okay. So adapter pattern is really a way where we can bridge two incompatible interfaces. They are completely different. Okay. And it would involve a single class, which is responsible to join the functionality of two different interfaces that are incompatible or independent. We can also use adapter design pattern to join or combine the classes together. I shouldn't say combine, but to work with the two classes. It would then convert the interface of a class into another interface that would be the base requirement. And it is a speciation of the polymorphism, in which the name is one name in multiple forms. Okay. So in the next question, we can define the functionality of the adapter pattern. We can say that it will convert the interface of a class into another interface based on requirement. And we would use it to bridge, right? Because there is also a bridge pattern to bridge two incompatible interfaces or independent interfaces. Okay, let's take a look at the example. Okay, so in this example, we're using musician and dancer, which is an external module. And I think I uploaded on the notes. So in the case, if you want to run the code with it, you gotta make sure that that file is also there, external.py. So we have a class called club and a class called adapter. In the club class, right, we have the string representation, but we also have a member method called organize event. And here we just simply would return some string, hires an artist to perform for the people. In the adapter class, we have obj, as we instantiated obj. And notice here that we use adapted methods. Okay. And we would update the adapted method for the dictionary. Again, we have another method for string, and that would show, right, the string for the obj. In the main, we simply define the object container, which is a list, and we would say that the jazz cafe would come from the club class. Roy Ayers is going to be from the musician class, and Shane Sparks is going to be from the dancer class. Then for our for loop, we want to use the for loop to go through the objects, which is defined here. So it's going to loop through that. If it does have the play attribute, right, and the dance attribute for the object, and we nest another if, then it would be play, then we would adapt the method to be able to show, right? But the event is going to be defined as obj.play. Otherwise, if it has the dance, then we would organize it for the dance. So if it's for the musician, we want to put it on the musician. If it's for the dance, we will put it on the dance. And here we would reference the adapted object. So your obj is going to be part of the adapter object. And for the parameter, we would use obj and adapter methods. Then we would print. And then lastly, we call main. So here it tells us that for our club Jazz Cafe, right, it just simply shows that it hires artists to perform for the people. And then it's going to plug in musician that will play music. And we saw that. Where is that here? And then the dancer. Okay, that will be for the dance performance. So what you have is you have musician and dancer interface that are different. And you can use the adapter pattern to tie them together. And that will be for the club. As an example. Any question? I would update that there. Okay. So you saw how adapter pattern works. If you wanted to test that, you can download the file that I uploaded or from the book. Okay, just a few more to go and then we'll be done. Last unit to cover, okay? Mostly code. Okay. Then in chapter 27, it talks about decorator pattern. And we talked about decorator before as decorator attributes. But for the pattern, it is used to add responsibility to an object dynamically and transparently. So what that means is that it's going to allow the user to add functionality to an existing object without changing it. So it would act as a wrapper to an existing class. And a lot of the times when you look at decorator, it implement memoization. Because we want it to store, right, the functionality of the methods of that class. So it needs to be able to have the space to be able to store that. And in this program, basically, we are going to perform mathematical computation using recursive function. And we would use memorize decorator on the recursive function to compute mathematic results. So it is faster because if you have worked with recursive function before, and if you don't allocate space if you don't use efficiency with time and space, what will happen is that in the large data set, you will lose you will lose some of the values, or it would eventually crash because it's not able to produce when it gets to the later values. Okay. So this is a way that we would approach Fibonacci. Okay. Clear this. Now on this one, I didn't upload everything, but there are several programs that go with this. Okay, but let's take a look at the main program. So we are going to use Func Tools. Okay, module, we import that. We have a method that will be memoized, so that's going to cache for the dictionary. So it does temporary storage for us, and that's important. Here we would decorate. We use the decorator here, Func Tools, and here's the wrapper. And the next part is gonna be the memoizer is gonna be for the caching purposes. So if the arguments is not in cache, we want to store it, and here is where we want to be able to put that into the we point to it. Okay, then we're going to return the cache and return memoizer. Then next we also have another decorator. This is going to be memoize. Okay, so we said earlier that we're able to use the decorator, right, with the method that we defined. So the third method here is going to be your number sum. So we're going to return the sum of the first n numbers. So we're going to add them. So here we're going to use a assert method. If n is greater than or equal to 0, then n must be integer that's above 0. If n is equal to 0, we would return n. Because if you think about Fibonacci, Fibonacci is a sum of the two prior numbers, right? So you would take n minus 1 plus n minus 2 is going to give you the next value in Fibonacci sequence. And that's what we're doing here, is that we have to seed it at 0 and 1, or 0 or above 0. So it would start at 0 and 1. So if we add 0 and 1 together, we'll get a 1. And then 1 and 1, we get a 2. 2 and 1, we get a 3, and so on. And that's how Fibonacci sequence goes. Then again, we have another decorator for memoize. So that's where we're going to be able to cache. And here is our Fibonacci function. So in the Fibonacci, we simply would say that if it's 0 and 1, we would return n, or anything above that, then we would have the Fibonacci sequence where the two prior numbers are added, n minus 1 plus n minus 2. Then in the main, we would time it. And then for the execution, okay, we would use the timer on the Fibonacci function and the num_sum function. Next, we have a for loop, and this is going to be for execution. So our fn is going to be with the first item. And we want to print out the function name. And then our t is going to be the second item, and we want to print the time. So simply it's going to tell us which function it's running and what time it has. This is basically for display. And then After that, we call main. So when we run this, okay, we add the numbers. This is the time for the number sum function. And for Fibonacci function, this is the time. You can print more than that for the result. You wanted to do like a sequence and so on. But this is a way that we can use Decorator Pattern for computation. It works best with recursive function. And as you can see, this implements memoization, which is a way that we would cache the value as its compute. So running sum would be good, factorial, Fibonacci, Lucas, those type of program where you would have recursive function, then you can implement this. So for 9, we can say that Decorator Pattern wraps the original class and provides additional functionality, keeping the class method signature intact. And we saw an example where we would use, right, we would define a function called memoize, and we would use the decorator to implement caching with object methods. Any question? Okay, so we got a couple more to go. Actually, a few more to go, and then we'll finish. So my plan for next week is we're still going to do a lab this week. So that way you have some practice with pattern. And so knowing how to do that so you can implement that into your project. Next week, I will cover final review for this class. Okay, so we will do that on Monday. If we get to finish everything, then I will give you Wednesday off to work on your project and your final review. Then we don't have to meet on Zoom for the following week. So just spend time working on your project and prepare for your exam. And then week 16, turn in your project and your final exam before the 15th. Okay. All right. And I didn't check. Actually, no, we already had the quiz previously. So, okay. Next, we're going to talk about bridge, facade, and proxy and MVC. So let's take a look at the bridge. And even the book doesn't cover all 23 of them. If you want to read about them, like I said Gang of Four book is probably the best one to refer to pattern. And pattern can be used in different languages like Java, C++, Python, C#. Okay, and so in this class we touch on Python, but if you understand the concept, it would be carried with the other languages. Bridge pattern, this is a structural pattern where we would take the business logic that could be in one class and we can make it into hierarchy, abstraction, and implementation. And in the abstraction, we can delegate calls for the implementation object. It would apply to all classes where all the implementations have the common interface. They are interchangeable inside the abstraction, so they are separate interface that would involve objects. Now, an example that we can probably relate to would be bridge pattern are like device drivers, right? So when you install your operating system, you should install your device driver. So that way you as the user can use the OS to access the device, like your graphic card, okay, your graphic adapter, or your USB or projection, whatnot. Okay. So the OS allow the vendor to be able to accommodate the drivers so that way it would be useful for us to access the actual device through the OS. So we need to bridge between the software and the hardware, correct? Is the driver. So in this program, when you run this one, I'm not satisfied with the example that's given here, but I'll show you why. Let's clear this. So kind of like similar to the other ones that we looked at earlier. This one is also a request tracking type of program. Okay. But unlike the other pattern, in this one, you see them, this is written a little different, where we would fetch the content, we would request the content and fetch the content as far as web. So as bridge have two hierarchy, we have the abstraction and the implementation, and this is what you would see here. So this section, this class right here, as you read the comment, you would see that it is the abstraction interface. And this is a reference to an object that would present to the next class, which is the implementer. So here is where you would maintain the object called imp, and that will be used here in the implementation. So for the next class, which is resource content fetcher, and this is going to be for the implementer. And this is going to work with URL fetcher, which also implement the implementer. So when we request a URL, right, it's going to access this method. And then that's going to bring it back here, which is then you would see how this is using the decorator for the abstract method here. Now for the main, or I'm sorry, the local file fetcher, this is going to be also an implementer interface. It's going to open and read the file. And then in the main, we simply have a URL fetcher, which is an object of URL fetcher class. Our interface is going to be the resource content. And we're going to use the URL fetcher here, which is the object. Then we are going to show the content from python.org. We're going to print. And then we will bring in the object from the last class here, which is your local file. And that's going to be able to show content for file.txt. Main, we're going to call main. So when we run this, pull this up. So what you have is, because there's SSL, right? And so when it times out, you don't have a session, your certificate verify it's failed. Okay. But ultimately you would output a text file. 7, 28. And this is what it looks like. Okay. Even though it gives you the error. This. So we do have some timeout requests on these. Okay. When you go through and you look at the trace back, you're going to see that we run into some exceptions. So to get this to fully work, I think that we need to fix the certificate issues, and then handle it with the session, and then it would be fully working where it won't give you these. So as you can see, it tells you that your certificate is expired. And we didn't really have it handle the exception in this like the other one, right? So you only able, here is where your only condition is that if it is successful, it's going to read the page and then print it. But we don't have anything to handle the error, right? Like 404 or 400. So this can be extended as you have an expired certificate. But the takeaway from this is that you do see how we are able to implement the bridge. Okay. Okay, so to define that, we would say that a function for the bridge pattern would be divide our general concept for our program into two class hierarchies, abstraction and implementation. Now for your final project, like I said, you can choose any type of pattern that you wish to implement that will be suitable for your project. And another structural that we're going to look at is going to be facade. So the purpose of facade pattern is to give you a higher level interface where we can break it down to subsystem. And that can be responsible for requests, especially when you're looking at servers. So after the bridge, chapter 29 talk about facade pattern. So this is a way that we can break down a complex system to subsystem. And we can hide a lot of the additional complexity from the client and we can simplify the interface by using Facade Pattern. So it looks simple on the outside, but complex on the inside, hence the name. So in the case where you have multi-layered system, you would be using the layers to communicate through their facade. And you would keep the layers independent. So the example that's provided here is where we would have a file server and we would create file and assign permission. Let's clear this. We are meeting the week of Thanksgiving. I can officially meet on Monday. Unofficially meet on Wednesday. So my plan is to meet on the 22nd, okay, to go over your final review. And so if we can fix everything that day or go through all the questions that day, then we don't have to come back on the 24th. That is the plan. You know, ideally, I would want to give you the day before Thanksgiving off. I know some of you are super busy, or some of you might be going out of town. So we want to take care of that. I don't want to wait till after Thanksgiving because sometimes people take extended vacation for Thanksgiving and then it becomes more of a hassle. So I wanted to address it on the 22nd and then give you the rest of the time to get through your project and prepare for the final. So yes, that is my plan, is the 22nd. Okay. All right. Okay, so then let's take a look at this particular example. Let's run this and we'll talk about the program. So we have a user class and a process class. These don't really have any kind of body. So we have pass and then we have a file class, right? So your server class, this is going to be your meta class, which is from ABC, right? We recall that we import that here. Okay. And then we also import enum for enumeration. Okay. So we have string representation that will be for your name. Decorator, we would do an abstract method here. And for our method, we'll just do a boot and then a kill method. So it's kind of like we would start the server. And then for our file server class, so that was a server class, that's your base. The file server class, this is going to be that this is going to have the state, which is I think that was defined in the ABC. So this is going to be your file server. We are going to instantiate state. We're going to boot. So here it's going to show, it's going to update the running state. Then if we kill, then it's going to restart. Otherwise, it's going to be zombie. Okay. Then we have another method to create the file, and we want to have username and permissions. So we are going to print out the file name, the user, and the permissions that's associated with that file. We also have a process server class instantiating also the state. We would have, similar to the other class, we would have running, right? And then restart when we kill, otherwise we make it zombie. For the process, we would check the user rights. So it's going to create a process to show your user and your name, right? So a lot of these, you don't see that there's not really any kind of body to it. It's just, we would see how we would be able to incorporate the class and the member methods in order to use it as a pattern. So here's your facade. You already defined your file server and your process servers, okay? So those are the two components that you want to tie into here, which is under OS, right? Then we are going to do a boot, and it's going to loop. Then it's going to create the file and set up the file permission. Then it's going to create the privileges for the user. So create process there. And then in the main, we simply gonna define OS object, which is the operating system class here. And then we're gonna start, we're gonna create file, and we are going to call on create process. Okay, so the output of that is, it tells you it's booting the file server, the process server. Those are two separate servers. And then it's gonna create a file and assign the permission. And then it's going to create the process for the user bar. So think of it, if you're familiar with Windows system, right? You have an Active Directory role that is started where it would have objects like user and groups. And then you have the file storage, which is a separate role. And we have to associate, right, the Active Directory objects, the user, to the actual files or drives that's on the storage server and assign permission to it. So on the outside, you're only going to see, right, the file that's created and the process that are created. So from the user standpoint, you would see that I'm going to be able to log in and access the files that I need, right? In the back, we're going to have all of these things that we have to boot the server. We have to, start the services. Then we have to create the file. We have to assign permissions. We have to create the user and give them privilege to access the system. So what the facade is that you simplify that for the user standpoint, but in the back, you have all of these additional processes that would be running and more complex level. So you're only going to give the user what the client they would see as a less complex, which is on the just the process side and the creating the files. Okay. So by definition, we would say that it would define higher level interface for any subsystem can use. And it would be responsible for sub requests or break down the request to sub requests. Okay, last three things. So long, right? And I cut 3 chapters from my original plan, but okay. So there are some example for the last 3. Sorry, just scrolling through here. Okay. The last 3 structural patterns that the book mentioned are flyweight, MVC, and a proxy. Okay, so flyweight reduce memory usage by sharing resources with similar objects. So it is state dependent and it uses immutable data or intrinsic. So if you have mutable data, then you cannot use flyweight. And recall earlier when we talked about how we would be able to cache using the decorator, we would use memoization and also flyweight to cache to avoid recomputation. Okay, so the example that give you there is for flyweight, and kind of like what you have seen in your threading, you would create a pool and then be able to reuse some of the already cached location. Okay, but at the end, when you print this, you're going to see that they are the same. MVC stands for Model View Controller. This is used to maintain applications without mixing business logic with user interface. And the example for this is given there. Another one that you can look at is proxy. We want to use proxy to execute one or more important actions first before we access the object. And on this, as you can see that it would, this is a way that we can access like information for the user. It's going to read, it's going to add the user. So before it accesses the object, it executes certain type of processes first, and that's what proxy does. Okay. So in a network sense, we always talk about proxy as a way that it filters first before it passes through, right? It is a traffic cop in a way but it checks you out first before it lets you through. So it's, think of proxy as it executes some kind of action to perform a filter before it actually implement the object pattern. Okay. And note that I did not cover the behavior ones, which are on the last, like maybe I want to say 3 chapters of the text. So if you like to, you can read those. Okay, so let's answer the last few questions. So number 12, which structural pattern executes one or more important actions before accessing an object? And that will be your proxy pattern. But make sure we know MVC and also your flyweight. I'll run this for you. So you can see here, right? It's storing in the same location for the flyweight. And then for the MVC, let's clear this. Yeah, it's plotting it for me too for the previous one. So it's still working on that. Okay. Now on this one, it asked me what quote would I like to see, right? And so here I have the quote specified here, and then I can choose. Okay, so you can test out the code and take a look at how we implement the pattern for those. Okay, you can pick the type of pattern you want to use. Okay, that's it for today. Stop recording real quick.